Should be okay, I think, if I do that. I think it's recording. Okay, and you can all see my screen. Yes, it is recording, so we'll make this available later. Okay, so let's begin. Firstly, our greatest concern is your health and well-being. We really hope you're in a good place. We know there's been major disruption to lives, jobs, income, a whole range of crazy things are happening. This week is, I'll just go to my announcements. You would have seen, you probably got this officially from the university as well. Census date this Friday. Census date means you can leave the university, well, unenroll from courses by the end of the 27th and not have any HECS or academic liability, okay? But there's also some special arrangements in place this year because we know things are rapidly changing. I'm not telling you this because I want you to leave. I'm just telling you because your options are open. I'm quite skilled and used to teaching in online environments. In actual fact, just to make you feel like you're looked after, I've researched in this area and published in this area of online teaching in tertiary education. So I'm quite excited about it in some ways because of the options that get opened up to us through this platform. But going back to my starting point, we do understand that this is a rapidly changing situation. Your health and priority is totally important. I'd really encourage you to stick with your studies if you can, particularly this subject, because there are some things in it which are helpful for your knowledge of infections and disease, which we'll look at in our second assignment, which we'll get to shortly. And also, it's good to have something to do. You know, you've got the textbook, you've got the online materials, you've got some direction. And just on that, we will get to the assessment items and the new subject outline, well, the updated subject outline. And I'll talk to it again then, but we're always open to getting requests for extensions and things like that. In this current environment, we're particularly sensitive to that. If, when we look at the assignments, there's any chance that you're not going to make a date for an assignment, just let us know. You can email me or Min. We don't need to know the details. If you're just struggling a bit with the study, talk to us. We can help you with strategies and resources. If you're not going to make a deadline, a due date, just let us know and we can arrange an extension, but we have to know, okay? And I see that the majority of you got your PLGs in too, which was great. If that slipped your mind, get it in. And as we all know, the PLGs were our personal learning guides, and with the changes that have happened recently, it's sort of a little bit redundant, some of that work. So firstly, I will just show you the things we're going to do this morning. We're going to go over our BHP materials. We might get a game of Kahoots in. We're going to basically talk about building that narrative, that story of how the universe, particularly up to threshold 3. But before I go on, does anyone got any questions or comments they'd like to make? If you don't, that's okay. You can write them, or you can just write no. So I get a bit paranoid sometimes that I'm sitting here talking to myself. All right, and you've got our contacts, so you can call us when we want. All good? Okay, thanks guys. That's really good. Nut with a smiley face from Isabella. That's always fun. Okay, first off, let's just have a look at the subject outline and notice some changes. So the book, of course, the text. By the way, how are you finding the text? It reads more of a novel than anything else. And it's a really good story. Ryan has a question. Missed it. Yes, Ryan, what's your question? I see Ryan has a question from name tag Georgia Smedley, is there something coming?
Oh, yeah.
Yeah, okay. I'm going to cover that for sure. Ryan, no problem. I'll just get to it in a sec, Ryan, you'll see. Okay, so we've got the text. Please keep reading the text. Okay. We're going to, this is where we're sort of up to. So we're finishing up with threshold 3. So you've worked on those threshold modules up till there. We do, and so for the next couple of weeks at least, we're just going to be focusing on our assignments. Yeah, our immunisation presentation and our citizen science, our science journal. And today we're going to talk about how the citizen science and the species and everything all come together. So we do have our test coming up on threshold 1 to 3, and it is on this Friday. I will open the test room at 9 a.m. and we'll close the test room Monday midnight. So over that time, you will have from 9 a.m. Friday morning till midnight Monday to take that test in that 20-minute window. Now, to go to Ryan's question specifically, you'll see here there's a folder, a new folder called Test Centre. You'll open that and you'll have an icon here to the Test Centre. Of course, it's not ready to go yet. From 9 o'clock Monday, it'll be sitting there. It's on a time lock thing, so it will appear on Monday at, it'll appear on Friday at 9 a.m. So all you have to worry about doing is going to the Test Centre window here. Okay. Now, of course, you've got that big time window from 9 a.m. Friday to midnight Monday to do the test. It's a 20-minute test with 20 questions. Once you start the test, you have 20 minutes to do it. After 20 minutes, the test automatically closes and saves your work. If you finish before the 20 minutes, you can save your work and log out. But I suggest you take the full 20 minutes. It is, of course, an open book exam, but there's nothing like some prep. So you can have some resources around you, but there's nothing like preparation. Okay, so, whoops, close that. Don't want to see all my emails. Okay, so subject outline. Okay, so for the next couple of weeks, we're really just focusing on getting our assignments working. Is that still this Friday? Sorry, I've taken my earphones out. Yes, this Friday from 9 a.m. and the test site's open till Monday midnight. Now, if that's not going to work for you, you just got to send me an email about it and we'll try to arrange another time. Okay, so the next couple of weeks, assignments. Then we'll get back to the thresholds. I'm going to try and keep these dates solid, these due dates. And as I said earlier, if they're not working for you, you just got to let us know and we can make arrangements. All the tests will be the same in that they'll open on a Friday at 9 a.m. of that week they're due, and they'll close on the following Monday at midnight. Okay. All good? Questions? And don't forget Mim's keeping an eye on questions too. Now, what do I want to show you? Our times. All good, all good, all good, all good. What are you sorry about, Mim? What did you do?
I just missed Ryan's question. I'm chasing a 2- and a 4-year-old this morning too. So.
Oh, are you?
Yes.
Woohoo!
Yes, fun times.
All right, no worries. So folks, you can see the timetable. We're holding this timetable sort of indefinitely. It might change a little, but I'll let you know. But for the next few weeks, it's not going to change. You know that at every time we're mentioned here, we're going to do a weekly presentation. It'll pretty much be the same one anytime, and you're welcome to log in. Today has been our biggest one with 20, but I've had between 5 and 15 at all the other sessions. So again, we're just trying to be flexible. You can come to any one. I suggest that you have a bit of a routine with your study though, and get a bit of a timetable and some discipline. Otherwise you can get a bit lost with what you've got to do. And we'll record at least one every week. Yeah, okay. Now in the gaps, I'm working with Min, Rose, who's down here with me on the Albury campus, and Kim, that's on the Bathurst campus. We're going to organise some informal times here as well when we open up the Zoom room as a staff room, for example. So it's just like, if you need to talk to us, we'll put in the dates when we are going to be in the room. So then, you can send us, try and ring us or email us at any time, and we'll get back to you as quickly as possible. But we'll also put in the times when we're available. So if you want to drop into the Zoom room, you can see us, talk to us, ask us questions, do whatever. So it'll be like consultation time. And by next week, we'll have these gaps filled with times when we're available, okay? Yeah, just mute your mics, folks. You get a bit of feedback. And we hear all sorts of things. Okay. Alrighty, so that's the organisational part. We'll get into do some work now. Who is up for a game of Kahoots? We've got 20 people. If we get more than half saying yes, we'll go ahead with it. Oh yeah, we're quick on the Kahoots. Yes. We love Kahoots. Now that's fantastic. I'll open it up. Of course, it's on threshold 3. What I've been doing is, yes, please, says Emily. I love that. What we have been doing is I've been providing some commentary around the answers, some commentary around the answers, and showing some other resources where practical. If that's too distracting, just let me know. And if it's good, say it's good. And if there's specific things you want to know about a question and answer, we'll go through it. But remember what we've tried to do in these thresholds is to use questions very, very similar to what's going to be in the online quiz. And the main point of these quizzes is to, and I don't have any toilet paper for a prize, the main point of these quizzes is for you to gauge your knowledge and knowledge gaps, okay? So I'll be quiet and we'll get the game going. If you haven't got Kahoots on your smartphone yet, the app, it might be a good thing to do. I will make these available. There we go. I will make these Kahoots public. Woohoo, look at you go. I will make the Kahoots public and search for other Kahoots quizzes. There's lots of good quizzes out there. Just take some of the answers with a grain of salt though, okay? Just check them. Wow, this is the biggest Kahoot ever. Woohoo! All right, if we keep getting this many people, we'll have to break into teams. So let's see, 28 people in on the screen, 25 players. I'll give people a couple of minutes. No, I'll give you a few seconds to log in. If you miss the start, it's okay. You can log in as we go. Okay, so I've got 25. We might start. You can come in at any time. The pin number's down the bottom of the page. Correct answers get points. The faster you answer, the more points are available. Ooh, correcto. Very good. Okay, yes, nuclear fusion. So what are we going to understand? Make sure we understand nuclear fusion. And fusion is when things come together. And nuclear fission is when things at an atomic level come apart. Okay, fuse, one S, fission, things break apart, two S's. So understand those phrases. It's really important. All right, good one. And of course, we need critical temperatures to get fusion to occur, and that's up around 10 billion degrees Celsius. 10 million degrees Celsius. The start of the universe was 10 billion. Ryan was quick on it. Well done. Yes, okay. Which of the fundamental forces compresses clouds and elements? It is, of course, gravity. These are the four fundamental forces. Gravity is the weakest, but it's had the biggest effect. Remember, this is about identifying your knowledge gaps or knowledge strengths. So what do? If this is a bit hazy and you're not sure about these, we go back. You can go back to the module, and the module will refer you to big history. So let's just jump into this section. Don't forget the unit guide. Certainly as I finalise the test, I go back to the unit guides to look for the accuracy of my questions and for further questions. There's lots of stuff in BHP, which is really, really good. But also don't forget these wonderful things down here, these extra sites. I think I'm the biggest fan in the world of Khan Academy. I can't recommend it strongly enough. And this particular video on the four fundamental forces is really fantastic. Okay, so all this should be sounding familiar. You should know a little bit about it. And again, just let me know if my comments are useful or you want me to get on with the game. Yes, they all start as a nebula. Okay, what's at the beginning of the end? Well, I guess hydrogen is present, but it's more than hydrogen. It's all the things that gather in the nebula, and it's the gravitational force that get applied as the nebula builds in mass. Okay, so what's the takeaway for this one? Life cycle of stars. Okay, get to know the life cycle of stars. And again, big history is I'll get into the right unit. The infographic is really fantastic. Of course, that's our go-to. When we're building this narrative, all right, this story of ours, we've got chapters. Each threshold is a chapter, right? And each chapter's got a heading. And then down here are the paragraphs and the interesting stuff of the story, the details of the story. And like all good stories, there's a link between the detail links the chapters together. Okay, so keep coming back to this this infographic. But life cycle of stars, there's lots of stuff in here of the life cycle of stars. These big histories are really good. And so are the crash courses. I'm just trying to find a crash course. Where's a crash course? Go with the big histories, and the crash courses done by the twins. There's one. These crash courses, really, really useful. Okay. Alrighty, I'll get back to Kahoots. Again, all this should be familiar. Okay, so what the Goldilocks conditions? We've got hydrogen and helium. That should be starting to look familiar now because we'll use this sort of notation for the first 5 elements. You should know: helium, hydrogen, helium, lithium, beryllium, and boron. Okay, we'll talk about them again in a minute. So what did we have? We had them. We had gravity and heat, tiny density in variations, and then the stars lit up. So a lot of people went for the green: gravity, heat, density of matter, new chemical elements. There's a little bit more to it, okay? The greater detail is the tiny density variations. So we'll come back to that in a minute, but those little tiny variations were really important for gravity to work. If everything was spread evenly after the, at the end of the plasma stage, when there was that burst of energy, simultaneously across all the universe, if that was even, perfectly spaced apart, totally uniform, we'd still be in the dark ages. No stars would have formed. Woo! China did COVID-19. Probably not the most appropriate name, but anywho. Yes. This is a tricky one in some ways because sometimes in science, things are counterintuitive, okay? You'd think that the biggest high mass stars would go the longest. It's a bit like, think of it as drag racing, okay? You see those great big drag cars with those massive motors and quarter of a mile in, just a few seconds, as opposed to a low mass star, which gets a little bit of fuel and can go for hundreds and hundreds of Ks. Yeah, so think of a low mass car as a low mass star as a 4-cylinder car, and think of the high mass stars as big dragsters or massive big V8s, right? They just go boom, all their fuel goes pretty quick. So just remember, sometimes things sound counterintuitive. Ryan, good moves. Great, yeah, all stars run out of fuel. They are burning fuel. They do run out. Eventually, there isn't anything else to fuse, or the helium is gone. So that's when they change. So understand now, how fast they use that fuel depends on what sort of star they are. IQ, 3 in a row. Nice. Nice, yes. Billions to trillions of years. Low mass stars, think of the analogy of the 4-cylinder car. For a little bit of petrol, goes on and on and on and on, can go on for a long time. High mass stars generally have a shorter life than low mass stars. And I threw in 380,000 years there because, of course, we had the Big Bang and temperatures were 10 billion degrees. Over 380,000 years, it cooled to 3,000 degrees, which is a bit funny saying it's cooled to 3,000. But that we had that hot, dense plasma state where energy and matter couldn't release until it got to 3,000 degrees. Then we have that burst of energy. The Velcro effect of the plasma stopped, and we had a burst of energy around the universe at the same time. It was 380,000 years after the Big Bang, which Abby knew and Sasha knew. What about our sun? Where's it in its lifespan? Well, our sun is a low mass sun. Yes, 10 billion years old. Our sun is 10 billion years old, which is a lot. And we'll talk more about it in a minute. Just fun fact, here's a sort of image of the sun, and we've got these massive solar flares. So the little light photon that's entering your eye right now, bouncing off whatever you're looking at, was thrown towards Earth through one of these solar flares, and it left the sun just over 8 minutes ago. And light travels at 300,000 kilometers a second. So the sun is 8 light minutes away from us. And to put that in context, our next nearest galaxy is Andromeda, and that's 64 million light years away. So it's crazy. It's hard to get your head around the scale of space. Fun fact, while that little light photon that's hitting your eye right now left the sun 8 minutes ago, thrust towards us from a solar flare, it actually started its life in the center of the sun, in the nuclear fusion happening here, 26,000 years ago. And then over that 26,000 years, it worked its way towards the outside of the sun, and then into a solar flare, and then to us. So while its journey from the sun to us took 8 minutes, its life began 26,000 years ago. Crazy stuff. Hard to get your head around some of these numbers, isn't it? IQ, screaming ahead. IQ is one of my favourite shows, which just goes to show how nerdy I am, I guess. So where is our sun in its life? Yep. Our life is halfway through its sequence. Its life is half over. If it was going to live to 50, it's 25. A bit like me. I'm on the downhill side of things. So 5 billion years to go. Okay? We'll live for 10 billion years, and it's 5 billion years old. And our planet and our solar system's about 4.7 billion years old. Okay? So we'll get into that in the next threshold, how rocky planets are formed. Ellie, screaming, 3 in a row. Yes, fantastic. Okay, so what happened in threshold 3? We get new chemicals. Yep. The stars did light up, but and I suppose we could say it is, let's just have a look. Let's not get too technical about it, but it is stars and elements. So don't be too hard done by if you put down the stars. What I do want to show you though in this is this picture, because I think it's fantastic. We can learn, you need some cues to how you remember stuff. And this image for me is really, really powerful. We can see the sun here, okay? And now we can see the periodic table and all these sort of atomic structures. This picture really speaks to me about stars being element factories, okay? And there's a difference between first generation stars and second generation stars. And we need to understand that. Just really briefly, first generation stars, well, the only thing that we had only elements in the universe were hydrogen, helium, lithium, beryllium, and boron. And our first generation stars went to nebula and formed through nebula and gravity and heat, and they ignited and they lit up, okay, and burned really hot. But when that fuel runs out, they expand into supergiants, yeah? And then when they're doing that expansion, they hit those temperatures of 10 million degrees, not billion, 10 million degrees. And then when they do finally sort of go through that phase and explode, for want of a better word, they put half a dozen or so elements, created half a dozen elements, more elements. So now the universe is much more rich. There's more than hydrogen, helium, lithium, beryllium, and boron, okay? So second generation stars, there were more ingredients that went into them. When they go through their sequence and burn and then go to supernova, we get those high temperatures of 10 million degrees again, and it's second generation stars that give us all the elements in the periodic table. So images like this are sometimes really good as study tools because you can talk to them. If I'm saying too much, just say. Okay, well done. IQ's getting ahead. It's that image again. It's really cool. Yeah, okay, let's go through these answers. Okay, so orange, yellow, a lot of people put. Gravity, hydrogen, helium, and heat. Yeah, that's okay. Green, no one put that, but we don't know. Dying star, we don't know. Well, that's gone. Blue, we don't know. Well, we do know because we're telling a evidence-based story. So we've got aging, dying stars, no fuels, and stars collapsing. And this talks about that heat. I hope that some of you are arguing with me about this and saying, no, I've got that right. Because if you are, that's really good because we've got to be testing our knowledge. But what ingredients? The aging, dying stars, ran out of fuels, and the stars collapsing. It's a bit more than what's in here. And 7 places up. Oof, Ryan's back on top. Halfway through, folks. Yeah, in a supernova. Why? Because we get those high temperatures. Now, just want to show you a couple of things again about the periodic table since we started to talk. No, I'll do that in a minute. Okay, so supernovas, again, life cycle of stars, critically important. Abby's back. Yeah, so after the plasma period, particularly to when the first stars light up, we call it the dark ages, and the universe was cold, dark, boring, and relatively empty. Yep, very good. Again, go back to BHP, look for areas that you need to work on. Yep, okay, elements arranged by atomic mass. No, they're arranged by their atomic number, which is a little bit different than their mass. Their mass is their sort of their weight, for want of a better word. Now, periodic table. Never any need to memorize the periodic table because we have them printed up. You can look at them. You need to navigate around them. I'll just come into this one. This is a little video in Stars and Elements. So this teacher explaining a periodic table. It's 5 minutes. It'll change your life about understanding periodic tables. And I particularly like the table they use because the elements are printed in different colours. There's solid black, blue, red, and hollow. Okay, so have a look at that one. Again, I've already said that I watch IQ is my favourite show, and I get even more nerdy. This is my favourite periodic table on the internet. It's a free one. It's really good. What I like about it is it just, for my old eyes, as I move to the different elements, they light up. So if we look at iron that we discussed a minute ago, we see that its atomic number is 26. Yep. So that means it has 26 protons. That's where we get its number from. I've moved off it, sorry. We can open it up and see and read more about that element, which is always pretty cool. It's Greek, it's Fe is its symbol, and that's from the Latin ferrum, which means iron, okay? Oops, wrong one. So its atomic weight, can you see the number down the bottom? Its atomic mass is 55.845, okay? And the numbers have to do with isotopes. We'll talk about that later. You just need to know what they are. So hydrogen, helium, lithium, beryllium, and boron. I'd like you to know as much about them as you can. The others, you just need to know how it's organised. You don't really need to remember it. What I like about this one is the noble gases. If we highlight here, we get to see all the noble gases, yeah? If I want to see the alkali metals, here they all are here, yeah? So how is it organised? We're organised in periods and we're organised in groups, all right? So my best analogy, my favourite analogy is a supermarket. You know you want some cheese and yogurt. You don't know exactly where the cheese and yogurt is, but you will know that the cheese and yogurt is in the dairy. So it's like the noble gases. You don't have to remember all the noble gases, but you know the noble gases are down this line here. Yeah? Make sense? If you want something you want some bread rolls, you don't even know exactly where the bread rolls are, but you know they're in the bakery. So you like wanting to know where the other non-metals are. Okay, you don't know where you don't need to know where every non-metal is exactly, but you need to know where the non-metals are. And that includes hydrogen over here. These ones down the bottom, why do we have this section down the bottom? Well, they're supposed to go in here. Yeah, but if we put them in here, the whole thing would be, 10 foot long, and then it'd be just not manageable. Does that make sense? So again, why is this important? Never memorize the damn thing. That's just stupid. But no, it's a way of organizing things. And here we've got, oops, where is it? See the colors up here? So when it's a solid C, a dark color like carbon, we know it's a solid. When it's blue, we know it appears as a liquid. When it's H, we know it, or when it's red, sorry, we know it's a gas. So black, solid, blue, liquid, red, gas. So even knowing that, you know that these are gases because they're red. You know that this is liquid because it's blue. And you know that this is unknown, right? These ones are unknown. What that sort of means is they're highly unstable. So when they do appear, they're gone just as quick as they are. So they're really hard to put a handle on. Does that make sense? So the more familiar you are with why we have periodic tables, the better. But you don't have to memorize it. And I'm sorry, I'm starting to waffle. I'll get back to the game. Troy H, here he comes. Yep, I'm glad you're all illuminated. We don't know because we're working on an evidence-based story. from 10 to the minus 37 seconds after the Big Bang, we can tell an evidence-based story about what happened, okay? And yes, when did stars form? Way after the Big Bang, 100 to 200 million years after. The Big Bang is somewhat of a misnomer, right? Remember, the phrase was originally developed by people who were highly critical of Hubble and his theory of an ever-expanding universe and reversing that to a singular point. So it was sort of, they were taking the piss out of him. They were really riding him hard and his Big Bang theory. But as evidence came about, we understood that there is evidence for this story, but the name Big Bang stuck. So when we think Big Bang, we think this, poof, here's the universe with all the stars. It is somewhat of a misnomer because the stars didn't appear straight away, a couple 100 million years later, in fact. Portia, on a roll. Yeah, it's interesting, isn't it? They spend most of their life in their main sequence, which is here. There's an average star or a low mass star. Now sun's an average to small star, low mass star, and massive stars. Illustrations and diagrams like this are really useful because they show us the sequence. We sort of automatically assume in our head some sort of equal portions are applied to these when they're not. So our sun's going to live for, it's a low mass star, an average star. It's going to live, it has a life span of 10 billion years. The vast majority of that was spent in main sequence. When our sun does go to become a red giant, it's going to expand beyond Earth. My very eager maid, Mercury, Venus, Earth and Mars will all be evaporated, absorbed into the sun, if you like. Then we have the planetary nebula. So understanding this sequence for high and mass stars is good, but don't be deceived. It's not at equal stages. Main sequence is the main one. Now, our sun was born out of a stellar nebula, right? And it wasn't the only sun. Several suns were born out of this. So this means our sun effectively has siblings, and we can tell those siblings because of their unique chemical signature, which we can read from a spectrometer. So this gives light to this study called galactic genealogy, where we can identify other suns and their siblings. It's really, really a fascinating area. So know the life cycle of suns and know it really well enough so these little sort of images don't deceive you with time. Okay, here we go. We're getting close to the end. Cool. Yes, a black hole or a neutron star. If it's got really, really high density, it'll collapse all the way into a black hole. If the density is not, otherwise the residual doesn't go to a black hole, it goes to a rock about 10 to 15 kilometers around, which is made up of all the residual matter from that nebula. So it's really high density, really high gravity. And if two neutron stars are attracted to each other, which happens, we call that a pulsar. Trina Sasha, climbing up there. Let's go. I think my commentary has put some people off. I don't know if everyone's playing still. Just yell out if you don't want me to commentate. Yep. Okay, 10 billion degrees. Just want to remind you about Kelvin. Kelvin is another measure. Celsius and Kelvin are both metric measures. So, you know, lots of 100, 0 to 100. And we know that 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water under certain conditions. It depends on your altitude, where you are in relation to sea level, the thinness of the air. When you're up high in the mountains, you can get water to boil at much lower temperatures, about 80 degrees. So that's a little tricky one. Now, kelvins. Kelvin is what we use in science, and Kelvin starts at absolute freezing, which is absolute freezing is minus 273 degrees Celsius. Yeah. So that means 0 degrees Kelvin is actually 270 degrees Celsius. So when we're talking about 0 in Kelvin, it's 200 degrees Celsius. All right. You don't need to concern yourself too much about this, except know this. Because of that difference, it's only just a couple of hundred degrees. When we're talking about this level of degrees, like 10 billion degrees, it doesn't matter whether it's Kelvin or Celsius. So sometimes they'll be presented almost interchangeably. Does that make sense? So don't be worried if you read an answer that doesn't say Celsius, it says Kelvin. Kelvin and Celsius are different, but when we're talking about massive numbers like this, they're pretty much the same. Okay? Just remember that. Fahrenheit is different again. It's not metric, it's the old imperial measure, and it doesn't relate. 110 Fahrenheit, I think, is something like 45 degrees C. It's really hard to compare them, so we don't use Fahrenheit very much. This will win you a pub quiz though. Minus 40. Minus 40 in Fahrenheit is equal to minus 40 in Celsius. That's the only common point. So bury that one away, because I'm sure it'll win you a pub quiz or something one time. Cara knows it. She's on it. Georgia B climbing back on 3 in a row. Yep. Okay. This is, you got to know the makeup of the original of the universe. Okay. Generally, we say hydrogen, which is H, 75%, helium, which is He, 25%, and trace elements of lithium, beryllium, and boron, right? Okay. That's easier than saying 74% helium and 74% hydrogen and 24% helium and 2% of those. This is the most correct answer, but be fully aware that we usually go 75, 25, and then trace elements of the other 3. And their atomic numbers in the periodic table are 1, 2, 3, 4, and 5. Why? Hydrogen has 1 proton, boron has 5 protons. So that's about as much detail as you need to know about elements, apart from understanding how the periodic table's organised. Good work. Yep, chemistry. Now, that's great. When we talk about evolution, we talk about Darwin. When we talk about cosmology and expanding universe and Big Bang, we of course talk about Hubble, although we should give particular attention to Henrietta Leavitt. But anyway, when we talk about chemistry, we're talking about Mendeleev. He is the father of modern chemistry. Do watch this crash course. It's only 10 minutes, but it just explains the extraordinary life of Mendeleev beautifully well. But we have to understand Mendeleev's contribution to chemistry, which is just remarkable. ways of knowing, intro to chemistry, they're really good too. And again, we're not trying to turn you into this is not a degree on chemistry, but you've got to get a bit of a grounding in all the disciplines, all right? So spend some time here. And of course, Marie Curie is one of the few women that get recognised for her contribution to science, and that's always worth acknowledging. And don't forget my video here and the birth of stars, again, the Khan Academy. Okay, back to the game. All good? Remember, it's not the getting these right, it's understanding where your knowledge is at, which is a reflection of your study program. Abby, 11 in a row. I think the record for this one, Abby, just to put a bit of added pressure on you, I think someone got 14 in a row the other day. I know they got 14 in a row, I just can't think of who it was. Very good. Yes, cosmic microwave background. Sometimes CBR, cosmic background radiation, sometimes CMBR, cosmic microwave background. Doesn't matter. It's the same thing. You've got to know about it. I'll come back to this in a minute, all right? But that's one of our key bits of evidence in the Big Bang Theory. Ryan's back in it. Now read this question carefully, okay? Read the question carefully. This is why I put this one in, because you have to read it. Exactly. It's a Big Bang. So all of the following are true. Without stars, without stars, we would not have, well, the heavy elements. Well, that's true. Without stars, we wouldn't have heat. That's true. Without stars, we wouldn't have light. That's true. Without stars, we wouldn't have the Big Bang because stars didn't come, well, late in the piece, okay? We needed the Big Bang first. Does that make sense? Okay. Next. Maddie, screaming. Can we pull back Abby? Last couple. Right, yes. Protons, electrons, and neutrons make up atoms. And the number of atoms, the number of protons determine what atom it is. Iron has 26 protons. So if we go back to our periodic table, and to find this table, you can just put in P table or just type in dynamic periodic table and it'll bring you. Let's have a look at iron. It's F6, right? So it's got 26 protons. If it had 25 protons, it'd be manganese. If it had 27 protons, it'll be cobalt, right? If it had 52, it would be tellurium, okay? So all we've got to know is how the atomic numbers are allocated. Okay, where'd I go? Cahoots. Last couple of questions. Oh, so, but what are these other things? What's a quark? Well, quarks are really small particles, and quarks make up quarks get together in different structures to make protons, electrons, and neutrons. So what's a particle? What's a diatom? I'll leave that up for you, okay? So when you see these questions, you've got to be thinking, oh, what are the other things? Don't just know the right answer. Nice, Abby. Can we pull it back? You do know, Abby, there's no toilet paper for a prize this time round. Okay, cosmic microwave background, not just microwaves, not electromagnetic waves, it's cosmic microwave background. But what are electronic electromagnetic waves, because they're an important part of astronomy, modern astronomy. Okay, this is an important map. This is called the W map. All right, now if we go into stars and elements, I'm pretty sure you can find something on the W map, or maybe even if I do a little search, W map Khan Academy, I'm sure they've got a good one on it. Map, no. No, I'll post up a better one for you. But what do we do with this? Let's go to this. See this image? So this is this gets a little complicated, okay? So bear with me. And you can have to do some, I won't give you a satisfactory answer, I know. So we have to do a bit of research on it. But the VMAP is, when we look into space, we can look into the past, right? Because things are so sparse and light takes so long to get to us, right? And it's so far away. So this is a map of the early universe. And the red show those tiny, tiny fluctuations in density and heat, yeah? It's not uniform. There are less dense areas and more dense areas. So this is what it was like in those 200 million years, okay? Or the 100 to 200 million years of the dark ages. And this is where gravity goes to work on these areas, yeah? And this is where the nebula started to form. The important thing to remember about this is if everything was totally uniform and equally spaced, we'd still be in the dark ages. But understanding this as a key piece of evidence is critical. Abby, 15 in a row, that is the new record, just to put a bit of pressure on you as we go into the last question. Yeah, gravity. Okay, now what's the key here? Fundamental force attraction between two objects that have mass, it's gravity. The other strong, and gravity, by the way, is the weakest of these forces. Strong nuclear force is the strongest, but it doesn't occur between two objects that have mass. It occurs at a subatomic level, all right? So again, yes, you got the right answer. That's great. What do you know about these things? Know more about them. And that's where that Khan Academy in this instance is really good. So I've just put up, is this helpful or boring, my commentary? This is the end. Let's see who the prizes go to, but I'm happy to have your comments about how useful you thought that exercise was. And I am working to make these thresholds public. Yay, Abby! No toilet paper for you though. And Liesl and IQ, good job. COVID from China. Okay, good fun. Comments, folks? Yes, no? Happy to do Kahoots next time we meet, yes or no? Or the next meeting, yes or no to Kahoots? Oh, great. I hope they're useful. Okay. Okay, and remember this is recorded so you can go back over it. Radio. Take a breath. Yes, Min, I think that they are good. And from, I've used them with year 1 to my final year students in environmental science and everyone, and adult groups, teachers, everyone seems to love Kahoots. Okay, take a breath. Yes, I'll make the Kahoots available for you anytime. I'd like to do mine weekly. So I'll make the first 3 available. You can just do a general search in Kahoots for public games. And I know there are some good ones put together by some teachers about the beginning of the universe. But just caution, they're not vetted. So you can assume that they're right, but just be mindful of the answers might need checking. But yes, do that. Sorry, I missed the start, but is the online test between till midnight? Yes, online test. Friday, 9 a.m. until Monday midnight. Okay, so that gives you 1, 2, 3, 4 days to do the test. And the test only goes for 20 minutes. And once you log on, you've got 20 minutes. Thanks, Emily. Okay, change of track. Right. We're going to start looking at our assignments. But before we do that, I want to talk to you about EndNote. Can I have some yeses and nos if you are familiar with EndNote? I just got a cup of tea delivered to me.
Au revoir.
Right, okay, I'm going to take you through EndNote, show you how to use it, show you the downloads I've got for you, and then you're going to love me forever because you're all in first year, most of the poor people. So this is going to change your academic life, all right? It's a wonderful, wonderful tool. It's been around for a long time and it's fully supported by the university, so you get lots of help from the library staff. So don't do this now, all right? But so don't follow along, but at some stage you need to go into here. So I've just gone into the EndNote installation guides. There are 2 videos. It looks exactly the same when you're using it, whether you're on Mac or PC, but there's just some different installations, all right? So here's the PC one and here's the Mac one. So watch these videos and it will guide you to download EndNote 9. I've also got this folder here for you, which is a library. I'll show you. So you need to watch this video, download EndNote, open up EndNote. You also need to download this folder, this file, and remember where it goes. So when you've got EndNote downloaded, now just stop for a sec. When you download any program, you know you're likely to get the usual problems. Your operating system might need updating, whatever. Okay, so there's usually some extra things that have to happen. I downloaded EndNote to my home computer because I use my work laptop, and before I could do it, I had to do a whole operations OS upgrade. So expect some of that stuff. So I'm just going with a normal upload. So when you open it up, it looks like this. Okay. You'll go through and open up. You'll open it up and it'll look like this. I'll just open mine and show you. Okay, but yours is going to be blank. There's going to be nothing there. Okay, but this is the library that I've given you. So then when you've opened it up, you go to File, Open a Library, and then you'll just navigate through. You'll navigate through to where you downloaded that library. Okay, and it's that EndNote library. And then you'd open that. When you've done that, your library will populate and it'll look like this. So I've put in 72 documents. Now I just want to talk you through this. If you don't get this far, you can email me, I can help out. You can also go to the library staff and they'll help out. Okay, and you can do that online. Then I've broken these 72 documents into subheadings that I think will be useful. So the first one is about citizen science. And that's going to be useful for our Science Journal article, isn't it? Yeah? Now, don't freak out yet. And I don't expect you to read all of these. I'm just giving you a heads up on the resources to make it easy for you to find some. I've broken them into climate change denial, and that's going to be useful. I just highlighted them for something else, so don't worry. I'll show you about that in a minute. So this is about climate change denial. And again, useful stuff in here for the Science Journal article. Conspiracy theories general. Well, they're just generally about studies being done on conspiracy theories. And that's going to help with understanding resistance to immunisation, why people are resistant to it. I've got an article on drop bears, which is just totally hilarious, which I want you to read. It's obviously mythical, but they've set it out like a proper research paper. We'll have a look at that in a sec. You've got science misconceptions and some teacher science literacy. So these are some general things about misunderstanding science and why teachers particularly need to have good science literacy. And the last one, of course, is on vaccinations, which has a direct effect, directly is the most important one in terms of time, because we're starting to look at that. Now, stay with me. All good so far? I assume so. These are in the library. Watch what happens when I click on this resource. Up comes the biographical information. Now, when you're using your library yourself and you find a good resource, you can download the information to go into this library, right? But it doesn't always come across perfectly. This one, for example, came across with the author's first name, so I had to just get it back to first initials. So everything in here is being vetted, and they're all perfect for APA 7, see? Right? Yours will do APA 6, and that's fine. If you want to upgrade to APA 7, I'll help you out. I'll do a little instructional video, but APA 6, fine. But anyway, what I want to show you is this. When you click on any one, the majority of mine also include a link. So if you click on that link, it will take you to the article's source. Now, in my own library, I've already done this and downloaded the PDF for each article. So each article I've got the PDF for. That's not always possible, and I'm not allowed to give that to you because it breaks copyright laws, right? So you've got to find them yourself. But you've got the hyperlink to the actual source. So there it is. There's that article. Ta-da! It's available. You can download the PDF. Now, watch this. I'll download this PDF. If it comes up and says you have to buy it, I'm not going to do that, because that's just telling me I'm not in the CSU system. All of these are available to you within CSU. If you get a bit stuck with it, what you can do is just copy and paste the name of the study. So I copy that. I open up, let's see, I need CSU library. I bookmarked it, I think. Sorry, I'll just get this up. So if I logged into CSU library and I just go to their Primo search, if I type in the title of the book, it's going, the article, it's going to take me to it. Okay, so it's a little bit of getting used to, but there's the article. Fantastic. I can download the whole thing, or I can download the abstract or read the abstract. Okay, so it's really good for managing your resources. Do you like that so far? So far, so good. So you initially, what you have to do is just go to our folders, EndNote, read the instructional video, download the library, right? There's more, but I'll get to it. Now, if for some reason you can't download the library, or you have a technical fault at some stage, what I've done is I've exported them, each of those groups. Yep, assignments due, same date. Same date. But if you're not going to make it, if you're not going to hit those dates, just let me know, all right? And we can organise an extension. The uni is changing from APA 6 to APA 7. EndNote, as you download it, will give you APA 6. There is a simple download you can do for APA 7, which I will do an instructional video for. Okay, it takes you about 30 seconds to do it, but I just don't want to do it now because it's an added level of complication we don't need, right? So stand by for that. But what I have done is taken each of those groups I've made and I put them into a Word document. So again, it's all in APA 7. So if I open up this Word document now, so I've just exported it from my library, and look, I've included the links here. So if you have trouble with EndNote for whatever reason, or while you're working it out, I've got these resources here already. Yeah, so you can just click on that and it'll take you to the resource. And again, if it takes you to sites outside CSU's library, just cut and paste the heading straight into Primo and you'll find it. Okay, and I'm feeling the love here because we have just provided you with 72 resources that have all been vetted, ready to go, and highly useful for your assignment. You do not have to read them all. I've just given you a selection from the selection. You might find better ones, but we've given you a start. No love out there for me? What's going on? I thought you'd be really happy. I thought there'd be flowers and virtual hugs and stuff coming down the line. No? Oh, it's really cool. If you guys add, now you're in first years. Yeah, don't forget Min. Min's part of this too. Thanks, yeah, feeling the love. Now, this is first year, right? I've got about, I don't know, I think I've got 8 different libraries and I keep about 200 references in each library because it's easier to manage than 1,000, right? But if you guys keep adding to this and make a library for each subject or a library for each area that you study, like if you're a history major, you might want to keep all your history stuff together. If you keep adding to this, by 4th year, you're going to have this massive library. But I feel like I'm selling you something. But wait, there's more, because this is the best bit. This is just the organizational bit. Let's just open up a Word document now. And I'll just close that one and I'll just open up a blank Word document. This is where this comes into its own. So new document, and it's just a blank one. And I'm going to start on working on my immunisation. Okay. So this is my my notes for my immunisation work. And of course I can't type, so just bear with me, okay? First thing I do is over here, I've opened that Word document, so I just click the word here. It just connects this document now with the library, right? And as you can see, I've got an EndNote menu ribbon there. I'll come back to that. You can play around and get to use this really, really easily, okay? But I'm just gonna go between EndNote and Word now. You can figure out the shortcuts as you get more familiar with it, alrighty? So here I'm starting my work, and I can't type. I do 2-finger pogo stick typing, and it takes forever. So I'm just making nonsense up, but you just have to imagine that this is me writing the start of my essay, yeah? Or piece of work that I'm doing. And I, now, that, oh, sorry, full stop. Now this statement here, this bit here, I know is referencing someone, right? Watch this. So I go back into here, it's on immunisation, so I've got my vaccination folder, and I know that this is McClure and Cataldi have said that, right? So I highlight them. I go now to this little button, the little insert citation button, the little quote mark, watch. I click that, magic, there it appears, correct APA 7. And look down below, what's it started to do? It started creating the reference list perfect in APA 7. It's perfect in APA 7 because I have vetted each of these to make sure that they're right. Yeah. So if this information is in the correct format, it will output in the correct format. Okay, so that's really good. So that means this sentence that I've written here, it's not a quote. I'm not doing quotes. I don't think there's much, unless you're doing a really big essay, you really shouldn't be quoting. You should be referencing, getting someone's idea, putting it in your own words, and then giving them acknowledge for it, right? So Now I'm going to say something really important, like in immunisation. Immunisation is critical for the survival of our species, right? That's a massive, big statement, isn't it? That's a huge thing to say. So if it's going to be, sorry, I'm a hopeless fella. I was away there. You know what I mean. I haven't got time to fix it up. You get what I'm saying. Right. Yes, all hail John and Min. Woohoo, thanks, Kimberly. Right, so this is pretty big. So this is a pretty big and important statement. So I need to back it up. So I know that the Lancet has said that. Yep, so I'm going to add that. I know that Beschk has said it. I'm going to say that. I even know that Wang and Barras have said it. I'm going to say that. So now look, here are those references in order. Didn't matter what order I picked them in, it put them in the right order. Yeah. This becomes a really powerful statement, doesn't it now? This is not just me saying that immunisation is critical for the survival of our species. Now, I've just made this up, remember, right? But if I did say a statement like that, I need to back it up. So it's appropriate for a really huge statement to have 3 or 4 references. And look down here, oh my goodness, there is my reference list getting created as I type. Now, I'd love to accept all your love and gratitude about this, but I didn't invent EndNote. It's been around for a long time. But can you see the advantages of using this? Now, go back to the beginning. Granted, whenever you put in a new folder, a new program, you usually get some hiccups and it's a little bit to work out. But the library will help you, the internet generally will help you, and I will help you. I've lost my mouse, my battery's gone flat. Now that's back now. Okay. Also, if you just need to make a reference list, you're not doing the insight stuff, you can just highlight the ones you want, right? Now, if I go here to File and Print, if I want to print them, oh, sorry, I don't want to print them. I can print them, and then I can open in Preview. It's just opening up. I think, where is it? I've got them, oh, I didn't choose them all properly. Okay, but what I'm getting at is you can export particular references. Alrighty? How did I do it the other day? I think I highlighted the ones I wanted. Yes, I highlight them all. I can print, or I can export. And I export it as rich text. Oh, I've already done it, so I'll just replace the one I've got. And if I go, because I know where it went to, oh, it's downloading, sorry. Anyway, you know what I mean? I'll just have that reference list done. So if I go now to go to my downloads, open up that, and there's that immunisation. You know what I mean? I just made that reference list. So as most second years will tell you, there's nothing worse than groveling around at 3 in the morning when you finish an assignment trying to put a reference list together. And if you use EndNote, you can beat all that. Cool? All good? Yay. Yes. Now the PowerPoint presentation. Here's my PowerPoint. So you can go to the subject outline. I'm nearly finished, folks, by the way. I've got about 10 minutes left. So when you're doing your PowerPoint for immunisation. Go to the subject outline and see what you have to do. Remember, you're just doing a presentation on immunisation and why it's important. It's 15 to 20 slides. And you know the best presentations only have 4 or 5 speaking points, right? So where are you going to put your information? Well, you go to view, you go to notes, and now you can put your notes in here, right? And if you're clever, you'll do your notes in Word first and use EndNote, and then cut and paste your notes into here. For every slide, you're going to do between 50 and 100 words. I'll make that bigger so you can see it. Okay, 50 to 100 words. There isn't a word limit, but I imagine that there'd have to be between 50 and 100 words to make sense of your 3 dot points. Yep. And remember, be clever, do it in Word first, use EndNote and cut and paste it into here. Perfect. And then just put your reference as a notes on the last one. Okay? Make sense? And then when you save as you go, of course, you can flick back to your view, normal view, just so you can play with your slides and stuff. But when you do save it, eventually when you're happy with it and you're ready to save it, just go to Save As and change it to a PDF. And it will, when it's saved as a PDF, it will save the slide and the notes. Ta-da! It's not that hard, okay? Good? Now, just going back to the subject outline, you will need, to make sense of this assignment, you're going to have to do, this has gone a bit kooky. You're going to have to do this modelling one. Modelling is really, really critical in science, yeah? What's going on here? So here's a module that we've put together. Hopefully you've done it. We've asked you to do it. It's good for your own science literacy right now because we're in the middle of a pandemic. So your own science literacy. Remember, you've got the social, cultural and intellectual capital of a community when you've got a degree from a university. So you've got to know shit, right? You've got to know your stuff. So here's some good stuff. And I've used, you can go and do this from, straight from Khan Academy, or I've put the links in here for you. Okay, and later we'll do one on climate change. So look at that module. Start reading the notes that I've given you in EndNote, right? You're going to have to get, I've given you a huge head start. I'd start with these ones, why it's important, okay? And you can do some general searching yourself. Fair enough? If you're having trouble with EndNote, don't panic. I've given you an alternate here. Get this one out and start with those. Yep, there's a fair bit of reading to do. Now, that's it for that assignment. All good? Questions? Questions about the PowerPoint on immunisation. You can go to the subject outline and read all the details about what it actually entails and what it looks like. We've given you pretty good instruction, clear instruction, I think. There it is, myth busting. Read all of that and you can start putting it together. If you do have questions, email me or Min, right? And we'll get back to you ASAP. Look at the marking criteria. Yes, I would think as a rough guide, 50 to 100 words on each slide in the notes. Because what are we going to mark? Look at the marking criteria. Communicates clear understanding of relevant topics. So this is where most of your marks are, in the notes. Yeah, and use of references. So between notes, between communicating to us and using proper references, there's 75% of the marks. So there's 10% of the marks, what's that? 25% of the marks are at the actual PowerPoint. 75% of them have to do with the content. So the notes are really, really important, and the references. No, you do not need to attach a marking criteria because we have very cleverly embedded it into our work. So there's no paper involved here. You will get your mark back. You'll be able to click on your mark in My Gradebook and it'll open up a marking rubric where we would have highlighted where we think you are and put some comments in. Okay, so it's all done electronically. You don't, no cover sheets either because it's going through East. So no cover. Just make sure your name is on the PowerPoint somewhere so we know who owns it, but no cover sheet and no matrix. We do that electronically this end. Good? Okay, I'll put up an instructional video about this and an extra little bit how to get to APA 7. You don't have to do much. It's just importing an instruction file and it all gets converted. I'll show you about it. It's easy. Okay. Good. So I just want to quickly talk about the other assignment, this one. The journal article, because we need to start thinking about it, right? It's 2,500 words. It's not due for a while yet, but we need to start thinking about it. What we've asked you to do in this is to identify a species that you're interested in writing in and talk about, and we're going to explore its response to climate change. Then we're going to talk about citizen science. And we've asked you to identify a species and then explore the Australian Citizen Science Association website. So here's the website. So you just go to it. You can become a member if you want, but it costs. You can just use it without being a member and it's free. So think of your species and go to this website and try and find a project that matches your species. Or if you haven't got a species yet, just go to the website and maybe that'll prompt you to identify a species. You go to find a project. And look, there's 504 projects at the moment. And you can search in lots of different ways. Mim and I will help you identify your species if you're having trouble, right? So initially, what do we want you to do? Get a species and hook into a citizen science project. Why? Because data gathering and data management is the hardest thing to do. Most citizen science projects also allow you access to the data that they've collected, and 99% of all citizen science projects in Australia contribute to the Atlas of Living Australia, okay? So if you go to this site, look, there's 13,000 databases to choose from. So if you go to this site and community needs, you can explore your area and you can look at different programs and things that are happening in your area, yeah? What I'm going to do over the next few days, this has just taken a little while to load up because it's busy, yeah? But it does search my area and shows me things that have happened here. Yes, you can, of course, yeah, whatever you wrote in the PLG was just your initial thoughts. They can change. But once you fix on a species, best to keep on it from now on. So you can, of course, you can change up to now, I guess, because we'll run out of time otherwise. What I'm also going to do is you can have a look at this yourself. If you go to educational resources, it's got some ideas on how you use ALA, but I'm going to show you, I'm going to do some videos on this so we can get some data from here. I'll change now at home because we have a bad back problem. Yep, great. Yep, and I'm assuming you're on the North Coast, you're talking about flying foxes. Yep, if you are, and that's great. I'm working also in a research project where we're developing a wildlife health app, and one aspect of that map is identifying hotspots and trying to get some pre-stuff engaged. So we know there's a heat wave coming. We know that it affects fruit bats, flying foxes really badly. Do we get our data from the Citizen Science website? Yes, we will help you get the data, okay? What I want you to do is contribute to the data. And if you can add some data, that's great. Okay, well, there's two things with that. We're sort of after two data sets. That's a really good question, James. How do we find a project on citizen science that says data relating to the effects of climate change? Well, we might have to use two data sets, okay? But we will help you with that. Not many will focus specifically on climate change per se. They will do a lot of counts and identification of species and stuff. So we'll help you with that climate change data. We'll provide some of that. One good thing about reading EndNote 2 is that this really puts you in the groove. I need it to open, where is it? Our EndNote file, it's here somewhere. Where'd it go? Did I shut it? There it is. No, that's not it. All the articles that we've given you are Science Journal articles. So it really puts you in the, I don't know where my EndNote's gone. It really puts you in the groove, yeah, for reading Science Journal articles. And if we are also going to give you a template, I haven't made it available yet because I'm just tidying up from last year, but we generally give you, I'll look at all the things that I can see that you can't. It's here somewhere. Oh, look, I'll put it in. We'll give you a template with the right headings and everything on it. We'll even give you a head start on stuff. So James, it's a very good question. For now, focus on your project, your species and your citizen science, and I'll put up some generic stuff about climate change that'll help you out. But we will give you a formatted Word document with all the headings and instructions about what goes into a journal article. But you can help yourself now, of course. Oh, what? It is open. I did shut it. Hang on. Open recent. You can help yourself now, of course, by reading some of these articles because they follow a set structure. And a good place to start, as I said before, down here, here's the Bolka article, the tracking of drop bears. It's obviously mythical. I mean, it's an urban myth, but the good thing about this article, it's structured really, really well. Abstract, introduction, bit about the species, distribution, the method they used, the actual case study, the data they presented, the concluding remarks, acknowledgements, references. That's pretty much the structure. Yes, Anthony, did you still want to elaborate on your questions, Anthony? And James, did I satisfy your responses? Has anyone got a particular species already? I know someone mentioned they're interested in fruit bats. That was Livia, very good. It's experiencing science. We want you to get into the community science project so you can experience what it's like to gather data. You can gather your own data and put it into the citizen science or keep it yourself. Look, I was having my coffee yesterday morning on my my little veranda and I had a king parrot in the yard. So, you know, that I can start citizen science with that. If you can't find anything, Liv, talk to us. We'll find something for you, okay? But I'm pretty confident. Do we add behaviour of the species groupings? But you just answered. Yeah, you can. Again, find your species, find a citizen science project and see what they're asking you to gather. If that doesn't fit with you, like you want to do a specific thing, talk to us because if it's not a citizen science project, I'm sure there's a study that has been done that we can refer to. Okay, we want you to engage with data, try and gather some data, but ultimately we're not going to rely on your data. I'm looking at watercolours from Griffith to Port Macquarie. Is that okay? The Citizen Science project is called Eye on Water. So it looks at watercolour. Yeah, that sounds pretty good. I'll defer to Min to that one in particular, but I imagine it's got to do with climate change and currents, and I think there'll be implications for a number of species and perhaps even water quality and algae. It sounds great, but Emily, good one, but I think I'll get Mim to specifically talk to you about that one because it's right in her ballpark. I'm sort of a generalist. Kim's an environmental scientist. Rose is a wildlife ecologist. And of course, Min is a marine biologist, commonly referred to as a beach bum, but I won't go there. Yeah, we chatted about that one. Should be great. Great. Yeah, that's really good, Emily. I'd like to do that. Aha. Okay. You'll take it being a beach bum. Yeah. All right. So, citizen science, field work can be done from home. If you've got it, we're all in varying degrees of lockdown. It's going to get worse, and it's going to, as in more severe, our conditions of lockdown, going to go for 3 or 4 weeks. Big danger if you go absolutely stir crazy. So getting into a citizen science project, getting into your big history stuff is a nice distraction. I'm just about done, guys. I'm happy to stay and answer specific questions. So is Nim. But if you want to buzz off, you can. I have taped this and I'll figure out how to make it available to you as well. And I'll put it under 2020-30 notes. My last sort of general comment to you is take care of yourself and keep in touch. If the dates don't work, just let us know. I know that this is called, we're all meant to restrict our social interaction, and I get it. I do think it is poorly named, though. I think what we really need to do is keep physical responses. So it's physical distancing. I say that because it's important to keep up your social stuff. So keep on your social networks, keep talking to people over the fence, keep talking to people across the road, keep talking to people on your through social media, okay? And the last thing I can say to you is is Brendan Murphy. Brendan Murphy is the Chief Health Officer of all of Australia. He is a genius, brilliant man advising the politicians, right? He is the go-to. I listen to what Brendan Murphy says. Now, the politicians listen to him too, and then go and make their decisions. But always go to what Brendan Murphy says, okay? Yeah, can be signed for not social distancing, that's right. And I implore you to follow all the recommendations. I'm just simply saying that the social distancing, I get why they called it that, but ultimately it's physical distancing. I think there's a danger of being socially isolated is really poor. So make sure you talk to your neighbours, use your social media, and keep up your social contacts in a safe way the best you can. That's all I wanted to say. But always, if you need a tip, and you know, the internet, Instagram, everything's flooded with advice. The news has something every minute. To see through all the rubbish, you know, use the ABC, but listen to what Brendan Murphy says is my best advice. Hey, Min, whales on the mid-north coast are great. Right, folks, if you want to hang around and ask questions, you can. The formal bit of it's done. I'm going to now